Hello guys, welcome to this lecture. In this lecture, we will be concentrating on Fibonacci series. We'll be completely exploring the nook and corner of Fibonacci series. Okay, fine. So getting into Fibonacci series initially, um, what is Fibonacci series? We will just take an example. Like a Fibonacci series is starting from 0, then we will take 1. 0 and 1 is base case. So initially we take the number called as 0 and 1. And then we form a series by adding these two numbers 0 plus 1 equal to 1. Then what is the last two terms? The last two terms is 1 and 1. So adding both these two, we'll be getting 2. So 2. What is the last two terms? 1 and 2. Adding both these things, we'll be getting 3. What is the last two terms? 2 and 3. Adding these two terms, we'll be getting 5. What is the last two terms? 3 and 5. Adding these two, we'll be getting 8. So adding these last two terms, we'll be getting 13. Adding last two terms, we'll be getting 21. Adding last two terms, we'll be getting 34. Adding last two terms, we'll be getting 55. Adding last two numbers, we'll be getting 89. Adding last two numbers, we'll be getting 144, and this keeps on going. This series is called as Fibonacci series. So you start with 0 and 1 and you start adding the last two terms to find the next term. Add last two term to find the present term, current term. Okay, fine. How we are going to implement this series using a recursive formula? We are not going to generate all these things. We are going to find nth Fibonacci number. For example, 10th Fibonacci number. So this is one Fibonacci number. And this is generally 0th Fibonacci number, 1th Fibonacci number, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th Fibonacci number, and goes on. So starting from 0th Fibonacci number. Okay, what is 0th Fibonacci number? It is by default 0 because we have taken 0 initially and then we have taken 1. So 0th Fibonacci number is always 0 and 1th Fibonacci number is always 1. That we should always remember. So we are going to start finding our answer from 2nd Fibonacci number. So by default 0th Fibonacci number is 0 and 1th Fibonacci number is 1. How we are going to formulate this into Fibonacci series recursive formula? Okay, we will just get into that. Okay, so what I will tell you is that what is the 5th Fibonacci? For example, we will just what is 5th Fibonacci number? 0, 1, 2, 3, 4, 5. 5th Fibonacci number is 5. So let us take a 6th Fibonacci number, 8. 8 is the 6th Fibonacci number. Okay, so what I can write is that what you are telling is Fibonacci of, that is Fibonacci of 6, that is 6th Fibonacci number. What is 6th Fibonacci number? 6th Fibonacci number is equal to 8. It is equal to 8. How did you got 8? 5 plus 3 equal to 8. What is 5? What is 3? If 8 is 6th Fibonacci number, then 5 is 5th Fibonacci number and 3 is 4th Fibonacci number. So Fibonacci of 6, if you want Fibonacci of 6, then you have to find Fibonacci of 5 and then you have to add Fibonacci of 4 also. You have to find and add. So Fibonacci of 5th Fibonacci plus 4th Fibonacci. What is 5th Fibonacci? 5. What is 4th Fibonacci number? 3. Adding both these things, we will be getting 6th Fibonacci number, Fib of 6. Okay, fine. Now, how to find Fibonacci of 5? I'll just tell you. How to find Fibonacci of 5? Fibonacci of 5 is equal to, that is 5. How did we got 5? 3 plus 2. What is 3 and 2? 3 is Fibonacci of 4 and 2 is Fibonacci of 3. That is 3rd Fibonacci and this is 4th Fibonacci. So Fibonacci of 5 is equal to Fibonacci of 4 plus Fibonacci of 3. Okay. Now how we are going to find Fibonacci of 4? Fibonacci of 4 will be equal to Fibonacci of 3 plus Fibonacci of 2. What will be Fibonacci of 2? Fibonacci of 2 will be equal to Fibonacci of 1 plus Fibonacci of 0. What is Fibonacci of 1? No need of any further recursion. Fibonacci of 1 already we told that it is by default 1. What is Fibonacci of 0? Fibonacci of 0 is by default 0. So what are end condition? We do not have only one end condition. We have having two end condition. If n is equal to 1 also we can stop. N is equal to 0 also we can stop. So First of all, how to generate this formula, how to generate from this, generalizing this Fibonacci of n, a general n, is equal to if this is n, this term is n, then what is this? N minus 1. What is 4? N minus 2. If n is equal to 5, then 4 is n minus 1, 3 is n minus 2. So for any n you can write, Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Fine. So this is the formula. This is a formula for recursion. Okay, this is a formula for recursion. So now, and what is the end condition? End condition is if you find Fibonacci of 1, you can stop and the answer will be 1. And if you got Fibonacci of 0 also, you can stop and the answer is 0, because 0 the Fibonacci number is 0 and 1 the Fibonacci number is 1 by default. So this is a stopping condition and this is a recursive formula or recurrence relation. This is what recurrence relation, this is what the recursive code, recursive formula also. Okay, so now what we are going to do is we will be drawing a graph for this recursion formula, and we are going to draw a tree for this. Yeah, so now what we are going to do is we'll be taking a initially, for example, in order to find Fibonacci of 5, we are just going to find Fibonacci of 5. So if we want to find Fibonacci of 5, if we are going to find Fibonacci of 5, so if we want to find Fibonacci of 5, what we need to do? We should be finding Fibonacci of 4. That is what the formula is, right? Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So we have to be finding Fibonacci of 4, which is n minus 1, and Fibonacci of 3. And then if you want to find Fibonacci of 4, then you should be finding Fibonacci of 3 and Fibonacci of 2, and you have to add both these things. So Fibonacci of 3 and Fibonacci of 2, you have to find both these things and you have to add both these things to get Fibonacci of 4. So coming to Fibonacci of 3, again you want to find Fibonacci of 2 and Fibonacci of 1. So you have to find Fibonacci of 2 and Fibonacci of 1. Okay, and Fibonacci of 1 is a stopping condition that we already know. Fibonacci of 1 is one kind of stopping condition, so you can stop. So you need not to again create a recursive structure for that. Okay, so Fibonacci of 1 stopped here, but Fibonacci of 2 have to be expanded because still we have not come to the end point of it. Okay, so on the left side this is Fibonacci of 1, and on the right side this is Fibonacci of 0. This is Fibonacci of 0. So adding Fibonacci of 1 and Fibonacci of 0. What is Fibonacci of 1? Fibonacci of 1 is 1 and Fibonacci of 0 is 0. So before executing all this answer, first of all we will completely expand it further. Okay, so on the other one side, if you see, you have Fibonacci of 3 and Fibonacci of 2. So Fibonacci of 2 can be definitely expanded on the left side, as well as it can be expanded on the right side also. So what is the expansion of Fibonacci of 2? The left side is going to be Fibonacci of 1, which is Fibonacci of n minus 1 generally. If this is Fibonacci of n, and this is Fibonacci of n minus 1, and this is Fibonacci of n minus 2, which is 0. Whereas Fibonacci of 1 and Fibonacci of 0 are the stopping points, so I have stopped here. So now coming to Fibonacci of 1. So everywhere if you see Fibonacci of 1 stopped, Fibonacci of 0 stopping point, Fibonacci of 1 stopping point. Now Fibonacci of 1, Fibonacci of 0 stopping point. Now coming here to Fibonacci of 3, Fibonacci of 3 also can be expanded to 2. One is Fibonacci of 2 and the other one is Fibonacci of 1. That is, if Fibonacci of 3 is considered as Fibonacci of n, and this is Fibonacci of n minus 1, which means that 3 minus 1, 2. And this is Fibonacci of n minus 2, which is 3 minus 2 equal to 1. Okay, so now Fibonacci of 1 is a stopping condition, so we stop here. So coming to Fibonacci of 2, we can expand it further because it has not still achieved its end point. So we'll be expanding for Fibonacci of 2 further also. So this is equal to Fibonacci of 1 and Fibonacci of 0, whereas both these are stopping conditions. So we are going to stop it here. So Fibonacci of 5 is initially expanded to Fibonacci of 4 and Fibonacci of 3. And Fibonacci of 4 is expanded to Fibonacci of 3 and Fibonacci of 2. And Fibonacci of 3 is expanded to Fibonacci of 2, Fibonacci of 1. And Fibonacci of 2 is expanded to Fibonacci of 1 and Fibonacci of 0. And this keeps on going for all the branches. And until you reaches either Fibonacci of 0, Fibonacci of 1, this keeps on going. Yes. Now we are going to solve it. So we'll just come to the leftmost subtree. And what is the value of Fibonacci of 1? 1th Fibonacci number is 1. So this is equal to 1. Okay. So what is the Fibonacci value of 0? 0th Fibonacci value. 0th Fibonacci value is equal to 0. So first of all, adding 1 and 0, because you have to add f of n is equal to f of n minus 1 plus f of n minus 2. So adding both this thing, we are getting 1. So that 1 is the answer of Fibonacci 2. Why? Because Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So adding the answers of both this, we'll be getting the answer of Fibonacci of 2. So 1. Okay, fine. What is the answer of Fibonacci of 1? Fibonacci of 1 answer is equal to 1. So adding 1 plus 1 will be the answer of Fibonacci of 3. So 1 plus 1 is 2. So Fibonacci of 3 is equal to 2. Sorry. Fibonacci of 3 is equal to 2. Now, coming to the other side of Fibonacci of 2, Fibonacci of 2 is expanded to Fibonacci of 1 and Fibonacci of 0. So, what is the answer of Fibonacci of 1? Fibonacci of 1 answer is equal to 1 and Fibonacci of 0 answer is equal to 0. So, adding both these things, we get 1 and that 1 is the answer of Fibonacci of 2. Okay. So, it is equal to 1. Now adding Fibonacci of 3 and Fibonacci of 2, we will be getting the answer of Fibonacci of 4. So 2 plus 1, it is equal to 3. So Fibonacci of 4 is equal to 3. Okay, so now coming to the other side of it, Fibonacci of 1, answer of Fibonacci of 1 will be equal to 1 and answer of Fibonacci of 0 will be equal to 0. Adding both these things, we get 1 and 1 is the answer of Fibonacci of 2. So Fibonacci of 2 is equal to 1 and Fibonacci of 1 is by default, we know that it is a base case equal to 1. So adding Fibonacci of 2 equal to 1 and Fibonacci of 1 which is equal to 1, adding both these things, we'll be getting the answer of Fibonacci of 3, whereas the answer is 2. Now finally, adding the answer of Fibonacci of 4 and Fibonacci of 3, we'll be getting the answer of Fibonacci of 5, which means 3 plus 2 equal to 5. So Fibonacci of 5 is equal to 5. And fifth Fibonacci, as we saw, it was 5. So this is the procedure of recursion that we are going to carry out. Okay, so the formula, initially what we did, we took the series and we represented that series as a recursive formula, and we have drawn a tree to trace the recursion that is happening. Now what we are going to do is we are going to write a implementation for it. Okay, so ash include stdio.h, okay, into main. Yes. So now I'll be initializing n is equal to 6 in my main function, and let me write a function that returns integer, that returns nth Fibonacci number, and the name of this is Fibonacci fib. And what it requires only one integer value for which we have to find the Fibonacci, nth Fibonacci, whatever the n value. Okay, so that n we are going to receive here. Okay, now tell me the ending point. First of all, we have to specify the base condition for any recursive code, right? So what is the ending condition? Okay, what is the ending condition? So the ending condition is automatically Fibonacci of 1 and Fibonacci of 0. Fibonacci of 1 and Fibonacci of 0. What is Fibonacci of, here n value is 1, here n value is 0. So if n is equal to 1 also, base condition, n is equal to 0 also, we have to stop any one. So if n value is 1, answer is 1. If n value is 0, answer is 0. So what we can write is that if the n value is less than or equal to 1, right? If the n value is less than or equal to 1, we can return n, because if n is equal to 1, we are going to return 1. Answer is going to be 1. If n is 0, answer is 0. So if n is less than or equal to 1, we will be returning the same n value, which is 1 means 1. 0 means 0, we will be returning back. So what is the base condition that we are going to write is, if n is, if n is less than or equal to 1, then we will be returning the n value. Why we are using the statement return? Because here we are keeping the return type of the function integer. So whatever answer that we are finding here, that answer have to be returned back to the main function. So whenever we want to do such a kind of operation, we are using return statement. If here it is void statement, then don't use return statement. Okay, so fine. Else, if this condition is not true, n is less than or equal to 1 is not true, what we have to do? We have to carry out the recursive procedure. So return, what is the recursive procedure? Fibonacci of, okay, Fibonacci of n minus 1. So Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So this is a recursive formula. Okay, so that's it. This is a recursive implementation of finding nth Fibonacci number. So what is sixth Fibonacci number? Is 8. So what we will do is, we will take a variable called answer, and we will call the function Fibonacci, and we will pass n value, which is 6. So sixth Fibonacci number is 8. So our answer have to be 8. So we will just print and we will check it. Okay, so percentage %d comma ans. Okay, so we will just go for compilation and we will execute and we will check once. Okay, so I'm just going for the compilation process actually. So Fibonacci.c. So is there any compilation error? No compilation error. So we'll be going for execution. So hello. So it's waiting for, it is not waiting for because we have already, yeah. So for the input of 6, it is giving us the answer 8. So sixth Fibonacci number is 8. What is seventh Fibonacci number? What is seventh Fibonacci number? Okay, so we'll just check once. So the Fibonacci numbers are 0, 1, 1, 2, 3, 5, 8, and 13. So seventh Fibonacci number is actually 13. So we will just check whether it is giving us the answer 13. Yes, it is giving us 13. So this recursive procedure is perfectly working. Okay, so is this the efficient way of writing a Fibonacci code? No. The next optimization we will be seeing in the next lecture. But before starting the optimization method, this is not the efficient way. There is one more efficient way. And before looking into that efficient way, first of all, we will calculate the time taken by this method. So if we know the time taken, by this method, using that we can discuss about how to optimize the time taken by this method. So first of all, we will write a recurrence relation for this recursive procedure, and then we will find a time taken by this recursive procedure. Okay, we will first of all write a recurrence relation and we will solve it. Okay, so we can take Fibonacci of n as t of n as usual, and checking this if condition will be taking 1 unit of time. Okay, 1 unit of time. And else, okay, else procedure, either if condition body part have to be working or else part. So we know very well that comparing if part, else part is having highest time complexity, so we can take this. So we can take this as Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, so what is the overall time complexity? T of n is equal to, okay, this is not sorry, writing this, instead of writing this as Fibonacci of n minus 1, we are going to write this as t of n minus 1 plus t of n minus 2 plus t of n minus 2. Okay, fine. So this is T of n minus, Fibonacci of n is taken as T of n. So Fibonacci of n minus 1 is taken as T of n minus 1. Fibonacci of n is taken as T of n. So Fibonacci of n minus 2 is taken as T of n minus 1. So T of n is equal to T of n minus 1 plus T of n minus 2 plus 1. And what is the stopping condition? The stopping condition is T of 0 equal to 0 and T of 1 is equal to 1. 0th Fibonacci number is 0 and 1th Fibonacci number is 1. So this is what the base condition is. Okay, so what I'm going to do is I'm going to ignore this plus 1 side in order to make the solving process very easy for you, to make you understand. We are neglecting the very smallest unit called 1. Comparing the two recursive calls, plus 1 is a very minute part, so I'm just cutting down the minute part. Okay, so let us take this recurrence relation and let us try to solve this. I think already I have shown you I shown you uh, the recursive formula. I mean, solving recurrence relation procedure for this kind of recurrence relation using characteristic equation method. Hope you remember that. Okay. So what we are going to do is, first of all, we have to convert the given we have to convert the given recurrence relation into a characteristic equation. Characteristic equation. So for converting this into a characteristic equation, what we need to first of all do, we need to convert all the right side term into left side. We are going to transfer all the right side terms to left side. So symbols will be, sign will be changing. So T of n plus T of n minus 1 will be converted to minus. So minus T of n minus 1, then plus T of n minus 2 also will be converted to minus T of n minus 2. Okay, so now it is equal to 0. So when all the right side terms are transferred to the left side term, automatically right side will not be having anything, which is equal to 0. Okay, how to convert this into a characteristic equation? Already we have said that the first term have to be taken as x square. So x square, and T of n is not preceded by anything. No constant is preceding our T of n. So no coefficient we are taking. No coefficient is there. Similarly, here also no coefficient. So we are going to simply take it as minus x. So first term is taken as x squared, second term is taken as x, and the third term is have to be taken as a constant. But there is no coefficient here. So if there is no coefficient, we can take it as 1. So minus 1 is equal to 0. So this is a quadratic equation. Am I right? This is a quadratic equation. So this quadratic equation only we are calling it as characteristic equation. So now we got a characteristic equation, and this characteristic equation is a quadratic equation, and we have to find the root of the quadratic equation. We have to find two roots, because if it is a quadratic equation, the highest degree is 2, and the highest degree is 2 only, we call equation as quadratic equation. So how many roots will be there? Maximum of 2 roots will be there. So how to find two roots? By using a formula. What is the formula? Minus b plus or minus square root of b square minus 4ac, and the whole divided by 2a is a formula for finding the roots of the quadratic equation. Before finding both the roots, first of all we need to know what is a, what is b, and what is c. What is a? A is the coefficient of x square. What is coefficient? There is no coefficient, which means 1. So a is equal to 1. Fine. What is the b? B is a coefficient of x. What is the coefficient of x? Minus 1. Minus 1. Including symbol also you have to be, including the sign also you have to be taking. So b is equal to minus 1. So what is the coefficient of, what is the value of c? C is equal to the coefficient of the constant. So the constant is actually minus 1. So we'll be taking exactly minus 1. Whatever the constant, that constant value you can take it here along with the sign. So a value is 1, b value is minus 1, and c value is minus 1. So let us substitute these values in the formula. So if b is equal to minus 1, then what will be minus b? So minus multiplied by minus will be, so product of negative sign and negative sign is positive. So this is equal to 1 plus or minus square root of, what is b square? B square means minus 1 square. Minus 1 square is positive 1 minus 4ac. So what is 4? 4a is 1. So 4a, 4 multiplied by 1 is 4. Then c is minus 1. So 4 multiplied by minus 1 is minus 4. So minus into minus will become plus. So this is plus 5. Okay, plus 5. Why it is plus 5? Because this term evaluates to give, this term evaluates to give, see, this term evaluates to give, I think plus, sorry, it is square root of 1 plus 4, because 4 multiplied by a 1. So 4 multiplied by 1 is 4, and 4 multiplied by minus 1 is minus 4. So minus 4 multiplied by minus is plus 4. Okay, the whole divided by 2a. What is a? 1. So 2 into a is 2 into 1 is 2. Okay, so 1 plus or minus square root of 1 plus 5 divided by 2. So how we can rewrite this into, this can be rewritten as 1 plus or minus, 1 plus or minus square root of 1 plus 4 is 5, square root of 5 divided by 2, the whole divided by 2. So 1 plus or minus square root of 5, the whole divided by 2. So what is the roots actually? Roots is going to, I'm not going to find the square root directly, let us take and write it. Okay, there's no need to simplify now. We will just look at we will just work on it later. But now what we are going to do is plus sign leads to one root and minus sign, negative sign, leads to another root. So first root, what is the first root? First root is equal to, first root is equal to 1 plus, all right, 1 plus square root of 5, the whole divided by 2. This is first root. What is the second root? Second root is equal to 1 minus square root of 5, whole divided by 2. So first root is 1 plus square root of 5 divided by 2. The second root is 1 minus square root of 5 divided by 2. Now what we have to do? Both are different root. I think already I have shown you this method. And coming to this characteristic equation method, there are two kinds of solution. One is if both the roots are different methodology. If both the roots are same, then there is a different methodology. Now both the roots are different. When both the roots are different, what we have to do? What we have to do? We have to write that t of n is equal to, we should be writing the equation. First of all, we have to take the first, we have to introduce the first unknown variable called as a. First unknown variable a, followed by the first root. Okay, we are going to take first unknown variable called as a, and what is the first root? First root is 1 plus square root of 5. So a multiplied by 1 plus square root of 5 divided by 2, and the whole power n. This methodology I have already taught you. So one unknown variable, either a or any unknown variable, we have to introduce, multiplied by so first unknown variable multiplied by first root, the whole power n. Okay, then plus second unknown variable called as b multiplied by the second root. Second root is 1 minus square root of 5 divided by 2, the whole power n. Whole power n. So first unknown variable multiplied the first root, whole power n, plus b, that is the second unknown variable, multiplied by the second root, whole power n. Okay, now what we have to do? We have to find the values of a and b. We have to find the values of a and b. How to find the values of a and b? We have the stopping condition, which is t of 0 equal to 0 and t of 1 is equal to 1. So now we are going to take n value as 0, and then we will be taking n value as 1. Okay, so now if you see, let us take t of 0. So if n value is substituted as 0, then t of 0 is equal to, t of 0 is equal to a multiplied by 1 plus square root of 5 divided by 2, the whole power n. What is n now? N is taken as 0. So we know already anything power 0 will be 1. Anything power 0 will be 1. So 1 multiplied by a will be equal to a, plus b multiplied by, again, 1 minus square root of 5 divided by 2, the whole power n. Always, what is the n value now? 0. So anything power 0 will be 1. So plus b multiplied by b multiplied by 1, which is equal to b. So a plus b equal to t of 0. What is t of 0? T of 0 is equal to 0. So t of 0, let us take it as 0. So a plus b equal to 0, and this we are going to take it as first equation. We are going to take it as a first equation. Okay, fine. Now what we are going to do, we are going to, so in this equation, how did we get this equation? We got this equation by substituting substituting the n value as 0 from base condition. Now we are going to take one more base condition called t of 1, whereas n value is equal to 1. So if n value is equal to 1, then we will be taking t of 1. So n value we are taking it as 1 equal to a multiplied by n value is 1. So anything power 1 will be the same number again we will be getting. So 1 plus square root of 5 divided by 2 the whole power 1 again will be getting the same 1 plus square root of 5 divided by 2 plus b multiplied by 1 minus square root of 2 square root of 5 divided by 2 whole power 1. Instead of n we are substituting 1, so we will be getting the same answer here. Okay, fine. Okay, fine. So now if you see here, we have this equation will see what is t of 1. What is t of 1? T of 1 is 1. T of 1 is equal to 1. So t of 1 can be substituted as 1. So a multiplied by 1 plus square root of 5 divided by 2 plus b multiplied by 1 minus square root of 5 divided by 2. Okay, 1 minus square root of 5 divided by 2. This is equal to 1. Fine. So now this equation can be taken as second equation. How did we got this equation? We got this equation by substituting, okay, by substituting the n value as 1. Okay, now we have two equations. One is a plus b equal to 0. The other equation is a multiplied by 1 plus square root of 5 divided by 2 plus b multiplied by 1 minus square root of 5 divided by 2 is equal to 1. So what we can do is that from equation 1 we can write, or we can also write equation 1 as a is equal to minus b, or otherwise b is equal to minus a. Both ways we can write. So what we can do is, instead of a we can substitute minus a. Okay, we can just start writing as minus a. Okay, so fine. So now what we are going to do is, in equation 1, okay, in equation 2, we will be substituting the answer that we got from equation 1. Okay, so after substituting the answer which we got in equation 1, what will be the answer? 1 is equal to a multiplied by the same answer. Okay, a multiplied by this one, 1 plus square root of 5 divided by 2, then plus, it is not plus for b, it is minus a, because what is the value of b? Value of b is minus a. So instead of plus b we are taking it as minus a. So minus a multiplied by, okay, multiplied by 1 minus square root of 5 divided by 2. Now what we are going to do is, we are going to multiply this a inside this bracket. Inside the bracket we will be multiplying it. So 1 is equal to, what is a multiplied by 1 divided by 2, because this divided by 2 is common to both your 1 and square root of 5. So multiplying a inside your 1 by 2, what it will be? It will be a divided by 2. Then plus what is a multiplied by square root of 5 divided by 2? It is a square root of 5 divided by 2. I just see, instead of giving division by 2 commonly, I have specified it as 1 divided by 2 plus square root of divided by 2. Separately I have given the denominator. Okay, then subtracted with, then again a multiplied by 1 divided by 2. What it will be? A divided by 2. Then minus multiplied by minus, again it will be positive. So plus A multiplied by square root of 5 divided by 2. So A square root of 5 divided by 2. So from this equation, what you understand, A divided by 2 minus A divided by 2 both will get cancelled. A divided by 2 and minus A divided by 2 both will get cancelled. What is this? A square root of 5 divided by 2 plus A square root of 5 divided by 2. Same term you are adding for 2 times. Same term same term you are adding for 2 times. So what we can write it as? This can be rewritten as 2 multiplied by square root of 2 multiplied by A square root of 5 divided by 2. So this multiplication by 2 and this division by 2 will get cancelled. So division by 2 and multiplication by 2 will get cancelled. So what this is equal to, A square root of 5 is equal to 1. So what we can take the value of A? A is equal to 1. Here it is in multiplication, so we can make it in division. So A is equal to 1 divided by square root of 5. So what is the value of A? 1 divided by square root of 5. And we know if A is 1 divided by square root of 5, then what is B? Minus A. So B have to be equal to minus 1. Okay, minus 1 divided by square root of 5. That's it. So we got the value of both our A and B. Okay, this A and B value we are going to substitute here. Instead of your A and B, we will be substituting the value of this 1 divided by square root of 5 and minus 1 divided by square root of 5. So let us take this equation and start substituting the value of A and B. Okay, so what is the value of A? What is the value of A? A value is 1 divided by square root of 5. So we will take the value 1 square root of 1 divided by square root of 5 multiplied by 1 plus square root of 5 divided by 2 the whole power n, plus what is the value of B? B value is minus 1 divided by square root of 5. So instead of B, start substituting minus 1. So from both the equation, see, from this is one part, 1 divided by square root of 5 multiplied by 1 plus square root of 5 divided by 2 whole power n is a separate term, and 1 divided by this is separate term. So from both the things, you got 1 divided by square root of 5 is a common term in both these things. So what we can do is we can take it in common outside. We can take it common outside. So T of n is equal to 1 divided by square root of 5 is taken common outside. Sorry, square root of 1 divided by square root of 5 is taken common outside, and inside, after taking it common outside, what will happen? This 1 divided by square root of 5 the whole power n, 1 divided by 1 plus square root of 5 divided by 2 the whole power of n will go inside, and then subtraction, because here it is the sign is minus 1 minus square root of 5 divided by 2 the whole power n will be coming. So simplifying, we got a equation like this. The final equation is 1 divided by square root of 5 the whole multiplied by 1 plus square root of 5 divided by 2 the whole power n minus 1 minus square root of 5 divided by 2 the whole power n. So which is the largest term here? Highest degree is actually power n. Power n is the highest degree. So we have to be taking either this term or this term. Okay, so which is the largest term? You know, this is a negative sign, so this is definitely not a maximum one. This is a positive sign, so this will be the maximum one. So this have to be taken as the time complexity. So the time complexity is considered to be order of 1 plus square root of 5 divided by 2 whole power n. I need to know what is the value of 1 plus square root of 5 divided by 2. Okay, what is 1 what is 1 plus square root of 5 divided by 2? So if you just calculate what is 1 plus square root of 5 divided by 2, it will be equal to 1.681. Okay, it will be equal to 1.6681. Okay, so you can just try it by your own. You will be getting this equation. Okay, so not 81, it is 18. Okay, so sorry. So this is order of 1.618 the whole power n, which is nearly equal to 2 power n. This can be nearly taken as order of 2 power n, but why I have done this procedure is I am just calculating the exact minute one we are taking, minute time complexity we are calculating. You can just go and surf in internet also, like Geeks for Geeks, any other website also. they will be specifying the time complexity of Fibonacci as order of 1.618 the whole power n, not as 2 power n. Okay, but they have not given in any of the websites. They have none of the websites they have provided this explanation, this derivation they have provided you. But I have just provided you uh, the detailed solving method also I have explained you, and I have found the time complexity of Fibonacci number as order of 1.618 whole power n, which is approximately equal to order of 2 power n. But exactly this is the order of 1.618 the whole power n. Okay, we started with Fibonacci numbers in this lecture. Then we derived a recursive procedure of solving Fibonacci series, and the formula is Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Then we draw a tree for tracing the recursion, how it is happening. Then we wrote a implementation, and this implementation was working fine, so that we introduce you to the recurrence relation format. And this type of recurrence relation, already in the solving recurrence relation video, I have already taught you this way of doing it. And it is found to be order of 1.618 the whole power n is the time complexity, which is approximately order of 2 power n. Whereas we already know that order of 2 power n is the worst kind of time complexity. And one more thing is that I will be continuing that in the next lecture. This final answer of recurrence relation is going to give you a magic. That magic I will reveal in the next video. Okay, this using this recurrence relation, this formula what you have found now will be going to do a magic. It's going to do a magic, and that magic I will reveal in the next lecture. Okay, so keep watching the next video, because we will also be optimizing the way to find nth Fibonacci number also. And we are not going to optimize it to order of n, we will be optimizing it to order of 1. So that is a magic that we are going to do. So please continue watching the lectures. Okay, so thank you.